Lesson 1.3, Solve linear equations. The definition of an equation is a statement where two expressions are equal. A linear equation can be written in the form ax plus b is equal to c, where a, b, and c are numbers, and x would be the variable you're trying to solve for. A value is considered a solution to an equation if substituting that value in for your variable results in a true statement. When asked to solve, you want to isolate your variable, meaning you want to get it all by itself on one side. It's kind of like order of operations, PEMDAS if you will, but backwards. When you have fractions, think about getting a common denominator and possibly multiplying by a reciprocal. The examples on the right would be similar to questions you could see on your non-calculator quiz. For our first example, 5m minus 2 is equal to negative m minus 2. On this example, we have a variable on each side of the equation. When we isolate our variable, that means we want to get them to the same side. What I like to do when I see two variables that have different coefficients is take the smaller one and move it over to the larger one. Therefore, between 5m and negative m, I notice that negative m is smaller. To move it over, I'm going to add it to the other side. 5m plus m, since we're adding, changes the coefficient or number in front to 6m. Well, that's a 6. There you go. So I have minus 2, and then I have negative 2 on that right-hand side. To isolate my variable, I'm going to move the negative 2 over by adding. Now over on the right, look what happens. Everything cancels out and we get 0. To get m by itself then, if I divide by 6, 0 divided by 6 is actually possible. We talked last week about numbers on the bottom being 0 and the fraction not existing. But in this case, 0 divided by any number just equals 0. And that means the only valid solution for m in this equation is 0. When working with fractions, again, follow our same process. We have 4/5 x plus 8 equals 20. X is our variable that we want to isolate. There's only one of them. Let's move that 8 over by subtracting. Oh, wow, and I don't know why I wrote 2. Let's try that again. Let's subtract 8. There we go. We still have 4/5 x. The 8's cancel. On the right, we get 12. Here's where we have a fraction as our coefficient. The easiest way to eliminate a fraction in an equation is multiply it by its reciprocal. And the reciprocal of 4/5 is 5/4. And if we do that on one side, we have to do the exact same process on the other. Like so. What happens here is, remember last week when we talked about multiplying fractions, any numerator can cancel or reduce with any denominator. The 5 on the top eliminates with 5 on the bottom. And the same with the 4's. When you multiply by the reciprocal, remember you get your identity, which would be 1x. And that isolates our variable. Now we just have to clean up the other side. Since I have a whole number of 12, or a counting number even, times a fraction 5/4, I'm going to put my whole number over 1. Let's see if we can reduce anything. The 12 and the 4 have a common factor. 4 goes into itself once and into 12 3 times. That gives us 3 times 5, or 15. And that's the solution for that equation. Here's our next example. 3/11 y plus 5 is equal to 4y plus 8. Again, we have a variable on each side like the problem up above, and again we have fractions like the problem up in the top right. In order for us to get y by itself, we need to move the variables over to the same side. I have 3/11 y and 4y. Noticing between the two of them, the 3/11 is smaller. That means I want to move that over first by subtracting it. We'll have 5 on the left, and I'm going to take this work right here and just move it over to the side, and I'll show you how to combine those without using your calculator. So let's bring that over here. If I have 4 minus 3/11, I'm going to put 4 over 1 so that they're both in fraction form. Now my common denominator of 1 and 11 is going to have to be 11. That means if I multiply 4 by 11 over 11, that would give us 44y, or 44 over 11y, giving it a common denominator with the minus 3 over 11y. And that's what you do in order to combine those like terms. Now if we look at that fraction, 44 minus 3, this is kind of aggressive, is 41. So that's what you get if you take 4y minus 3 elevenths y without your calculator. 41 elevenths, and then we have plus 8. I know, this is messy. If we move that 8 over, we're going to subtract it, like so. And we get 5 minus 8, which would equal negative 3. Negative 3 equals 41 elevenths y. I know, y, right? Exactly. All right, to get y by itself, if it's being multiplied by a fraction, we talked about this up above, we're simply going to multiply it by its reciprocal. So we have 11 over 41. On that right-hand side now, we know that if we have a number on top and bottom, there's those 41 and 41, and the 11 and the 11 cancel out. That gives us just y on that right-hand side. Over on the left, 11 for 41 times negative 3. Again, I'm going to put negative 3 over 1. It doesn't look like negative 3 goes into 41, therefore I'm just going to multiply straight across. 11 times negative 3 is negative 33. And 41 times 1 is in fact 41. Negative 33 over 41 does not simplify, therefore that is our final answer in simplified fraction form. Oh, look at this one. There's more fractions. How fun. We have 2d over 3 equals 3d over 5 plus 4. Again, these are problems we can do without a calculator. It just takes a little practice, and you'll find it's not going to be quite as intimidating as it might look. Now for this one, you may not recognize which fraction is bigger or smaller. We have 2/3 and 3/5. So I would look at this problem and say, well, at least I know there's a 4 on that right-hand side. So if I move that 3d over 5 over, we're closer to getting that variable isolated. I'm going to subtract 3d over 5, and this is in fact slightly smaller than 2/3. We're just going to have to get that common denominator. Okay, so on that right-hand side, that whole thing cancels out, and we get equals 4. On the left-hand side, we have 2/3 and 3/5. Thinking about what they both go into, 3 and 5, the smallest denominator would be 15, what we get when we multiply 3 times 5. What we'll have to do here then is I'm just going to take this over here to set it up again. You can write your work in any space. I just like to separate it from the equation so it doesn't get really messy. If I multiply the top and bottom of the first fraction by 5, I get 10d over 15. In that second fraction, to get 15 in the denominator, we're going to have to multiply top and bottom by 3. And that would be minus 9d over 15. If we have 10d minus 9d, that would be 1d, or just d over 15. And that's what the left-hand side of our equation equals, d over 15. And all of a sudden this becomes quite a bit easier, everybody. If we have d over 15 equals 4, and we want to multiply by the reciprocal to get d by itself, we really just need to multiply by 15 over 1. And on the right, that would just be by 15. 15 over 1 on the left cancels, and we get d isolated. On the right, 4 times 15. Write that out on the right-hand side, or do this mental math. If you double 15, you get 30, and if you double 30, you get 60. And that would be 15 4 times. Therefore, d is equal to 60. Let's look at a different form for an equation, solve using the distributive property. If you have parentheses and you're trying to isolate a variable, your goal would be to distribute any coefficients in to eliminate the parenthesis. Once you've done that, simplify each side by combining like terms, and then go ahead and isolate your variable. Let's try the 2 on the right. Our first equation has 3 times 5x minus 8 is equal to negative 2 times negative x plus 7 minus 12x. Notice we have 3 different variable terms that have x in them. Our goal will be to eventually get x on one side. On that left side, though, we have 3 times 5x minus 8. Let's eliminate that parenthesis by distributing 3 in. 3 times 5x would equal 15x. Minus 3 times 8 is 24. And now what we can do with those terms is move them around if needed. But when they're stuck in that parenthesis, that's more challenging to do. On the right-hand side, same idea, but we have negative 2. If we distribute negative 2 in times negative x, that actually becomes positive 2x. And then negative 2 times positive 7 actually changes the sign to minus 14. And then that minus 12x is just a term we have after that parentheses. The second thing I said to do was combine like terms. On the left-hand side, we're stuck with 15x minus 24. But on the right-hand side, we have 2x minus 12x. Be careful with that. That's actually negative 10x when we combine them on the same side. We're just combining like terms. From here, we now have a model up above, that very first example, where we had the variable on each side. Let's move one over. I have 15x and negative 10x. I'm going to move negative 10 by adding it. There's that PEMDAS, but backwards. 15x plus 10x is 25x. And then on the right, we have negative 14. I'm going to add 24 to move it over. And we're left with 25x. The 24's cancel. Negative 14 plus 24 is 10 on the right. Last step, to get x by itself, divide by 25. And again, we are not using a calculator, but this reduces. 10 doesn't go into 25, but 5 does. 5 goes into 10 twice, and 5 goes into 25 5 times. Therefore, our simplified answer in fraction form is 2/5. All right, this is a you play, or you try right now, not you play. I don't know what that means. Let's take a look at that second equation. I'd like you to pause the video, solve for x, and then press play. Did you get negative 7? I hope so. I distributed the 3 on the left, the 5 on the right, combined like terms, and isolated my variable. And this is where we'll stop with our lesson for 1.3. We'll finish the rest of the problems on the back in class.